Now, take the next question. Prove that cot A plus cot B plus cot C is equal to A square plus B square plus C square by 4 delta. This question is very, very, very important. Let us take LHS first. LHS is cot A plus cot B plus cot C. Now from trigonometry we know that cot can be written as cos by sine. So this is cos A by sine A plus cos B by sine B plus cos C by sine C. Now from cosine rule we can write cos A as B square plus C square minus A square by 2BC. Then sine A we are writing as it is. Then cos B we can write it as A square plus C square minus B square by 2AC. This is cos B from cosine rule. Then we have sine B, we write as it is. Then cos C we are writing it as A square plus B square minus C square by 2AB. Then sine C we are writing as it is. But from the formulae we know that 2BC sine A is 4 delta and 2AC sine B is 4 delta. 2AB sine C is 4 delta. Because delta is equal to half BC sine A and half AC sine B. And also it is equal to half AB sine C. So that's why we got 2BC sine A as 4 delta. Now this is B square plus C square minus A square by 4 delta plus A square plus C square minus B square by 4 delta plus A square plus B square minus C square by 4 delta. Now denominators are all same, add the numerators. B square plus C square minus A square plus A square plus C square minus B square plus A square plus B square minus C square by 4 delta. A square minus A square cancel. B square minus B square cancel. C square minus C square cancel. So that is A square plus B square plus C square by 4 delta, and this is RHS. Very, very important question. Now take the next question. In a triangle ABC, show that tan B minus C by 2 equals to B minus C by B plus C cot A by 2. So first what I will do is I will take RHS. RHS is B minus C by B plus C cot A by 2. Now from sine rule we can write B as 2R sine B. Minus C we can write as 2R sine C by 2R sine B plus 2R sine C into cot A by 2. Now 2R, 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 2R cancel. So sine B minus sine C by sine B plus sine C into cot A by 2. Now here for the numerator we will apply sine C minus sine D formula, and for the denominator we will apply sine C plus sine D formula. So from trigonometry transformation we know that sine C minus sine D is 2 cos C plus D by 2 sine C minus D by 2. So that is 2 cos B plus C by 2 sine B minus C by 2 by 2 sine B plus C by 2 cos B minus C by 2. into cot A by 2. 2 cancel. So cos by sin is cot B plus C by 2. Sin by cos is tan B minus C by 2. Then cot A by 2. Now cot B plus C by 2 can also be written as 90 minus A by 2. Tan B minus C by 2. Cot A by 2. Cot 90 minus theta is tan theta. So tan A by 2, tan B minus C by 2 into 1 by tan A by 2. Tan A by 2, tan A by 2 cancel. That is tan B minus C by 2. This is LHS, hence proved. Now take this question. This is very, very important. This model P1, P2, P3 model problems are very important. So the question is, if P1, P2, P3 are the altitudes of triangle ABC, then show that 1 by P1 square plus 1 by P2 square plus 1 by P3 square is equal to cot A plus cot B plus cot C by delta. So whenever these P1, P2, P3 problems are given to us, first we will draw a triangle. Then we will drop the perpendiculars from each vertex. Now this is 90 degrees, this is 90 degrees, this is 90 degrees. This is A, B, C. Now the side opposite to A is small a. The side opposite to vertex B is small b. And the side opposite to vertex C is small c. And this is D, E, F. Now AD is P1, BF is P2, CE is P3. So now you can see, since P1, P2, P3 are the altitudes of triangle ABC, then we have delta is equal to, see what is area of triangle, half base into height. If we are taking BC as base, then we will get half base into height. And if we take AC as base, then we will get half BP2. And if we take AB as base, then we will get half CP3. Now we got the values for delta. So from here we will get P1 is equal to 2 delta by A. P2 is equal to 2 delta by B. P3 is equal to 2 delta by C. Now you got P1, P2, P3. After this we will take LHS. LHS is 1 by P1 square plus 1 by P2 square plus 1 by P3 square. That is 1 by 4 delta square by A square plus 1 by 4 delta square by B square plus 1 by 4 delta square by C square. Now we take the denominator part to the numerator, so it will become reciprocal. So that is A square by 4 delta square plus B square by 4 delta square plus C square by 4 delta square. Now you add the numerators, A square plus B square plus C square by 4 delta square. So this is equation number 1. Now let us take RHS. RHS is cot A plus cot B plus cot C by delta. So this is nothing but, if suppose we take this as cot as cos A by sin A plus cos B by sin B plus cos C by sin C by delta. So now cos A we can write it as B square plus C square minus A square by 2BC sin A. And cos B we can write it as a square plus c square minus b square by 2ac. Then we already have one sin b, we are writing as it is. Then cos c is a square plus b square minus c square by 2ab. Sin c we are writing as it is by delta. Now, like how we have done in the last problem, 2bc sin A can be written as 4 delta. 2ac sin B can be written as 4 delta. 2ab sin C can be written as 4 delta. So we are adding the numerators. B square plus C square minus A square by 4 delta plus A square plus C square minus B square by 4 delta plus A square plus B square minus C square by 4 delta whole divided by delta. Now we will take the LCM. So we will get B square plus C square minus A square by, or let us add all the numerators together, plus A square plus C square minus B square plus A square plus B square minus C square by 4 delta, and already one more delta is in the denominator. Now a square minus a square, b square minus b square, c square minus c square cancel. So that is a square plus b square plus c square by 4 delta square. This is equation number 2. And this is RHS. So we got LHS value also and RHS value also. Both we got it as a square plus b square plus c square by 4 delta square. Therefore LHS is equal to RHS. Take the next question. This is very important. It was asked last in TS March 24. So the question is, if A is to B is to C is 7 is to 8 is to 9, then find cos A is to cos B is to cos C. So what is given to us? A is to B is to C is equal to 7 is to 8 is to 9. So we can write A is equal to 7k, B is equal to 8k, C is equal to 9k. Now cos A is equal to B square plus C square minus A square by 2BC. So B is 8k, so B square will be 64k square. C square will be 81k square minus 49k square by 2 into 8k into 9k. If I take k square common and if I cancel it out, we will get 64 plus 81 is 145 minus 49 by 144. So that is 96 by 144, which is equal to 2 by 3. Now the same way we will find out cos B. Cos B from cosine rule is a square plus c square minus b square by 2ac. So a square is 49k square plus c square is 81k square minus b square is 64k square by 2 into 7k into 9k. So 49 plus 81 is 130. 130 minus 64 is 66 divided by 126. That is equal to 11 by 21. Next, cos C. Cos C formula is a square plus b square minus c square by 2ab. So a square is 49k square, b square is 64k square minus 81k square by 2 into 7k into 8k. So this is equal to 49 plus 64 is 113 minus 81 by 112. So 113 minus 81 is 32 by 112. So we are cancelling by 16 table. 16 twos are 16 sevens are. So after getting cos A, cos B and cos C values, we will find the ratio. So what is cos A is to cos B is to cos C? Let us write the values. 2 by 3 is to 11 by 21 is to 2 by 7. So if you take the LCM of 3, 7 and 21 is 21. So 3 sevens are 21, so 2 sevens are 14. Here 21 ones are 21, so 11 ones are 11. Then here 7 threes are 21, so 2 threes are 6. So this is the final ratio. Now take the next question. Show that a square cot A plus b square cot B plus c square cot C is equal to ABC by R. So in these three terms, let us first write the LHS. LHS is a square cot A plus b square cot B plus c square cot C. Now you can see these three terms are in order. Where you have A in the first term, there you have B in the second term, and there you have C in the third term. So this can be generalized as sigma A square cot A. So let us solve for A square cot A, and then we will apply it for all the three terms. So over here, you can see we can write from sine rule, A is 2r sine A. So A square will be 4r square sine square A. And then cot A can be written as cos A by sine A. So one sine A get cancelled. That is sigma 4r square sine A cos A. Now from here, if I take 2r square into 2 sine A cos A, then from trigonometry we know that 2 sine theta cos theta is sine 2 theta. So this is, if I take 2r square outside, sigma sine 2a. So that is 2r square into, if you expand the summation, you will get sine 2a plus sine 2b plus sine 2c. Now we are proving this using transformations. So 2r square into sine 2a we are writing as it is. Now sine c plus sine d is 2 sine b plus c cos b minus c. So that is 2r square into, now sine 2a we can write it as 2 sine a cos a plus 2 sine b plus c is sine a, because b plus c can be written as 180 minus a cos b minus c. Now if we take 2 sine a common, we will get 4r square sine a into cos a plus cos b minus c. Now cos a can be written as, now cos b minus c I will write first, then cos a we can write it as minus cos b plus c. Now let's see how to continue. So that is equal to 4r square sine a, and now we have cos b minus c minus cos b plus c. That is the formula for 2 sine b sine c. So that is equal to 8r square into sine a sine b sine c. Now from the properties of triangles formulae, we know that sine a can be written as a by 2r, sine rule. Sine b is b by 2r. Sine c is c by 2r. 2 into 2 into 2 is 8. 8 and 8 cancel. R into r, and here r square get cancelled. So you will get ABC by r. This is RHS.